All right, so today we're going to be doing assignment number 5, and it's all about parallel and perpendicular lines and slopes. This is something that you also did in Algebra 1. You reviewed it in geometry. We're just talking about it one more time here in Algebra 2 to make sure that we understand the relationship between parallel and perpendicular lines and their slopes and how to write equations of parallel and perpendicular lines. Let's go ahead and get started. So we want to find the slope of the following line. And so let's assume that, and it's kind of gray area here as far as where this line goes through, but let's say it goes through this point here and it goes through this point here. We want to find the slope of that line, so it's going to be down 3 and over 2. So the slope is negative 3 halves. But then we want to find the slope of these parallel lines. So if we have all of these parallel lines on here, we can pick any one of them. Let's just say I pick this one. It goes through, let's say, this point and this point. It's also going to go down 3 and over 2, which means the slope is the same. So we should realize then that if the lines are parallel to each other, the slopes are the same. All right. Well, let's talk about perpendicular lines. We can find the slope of this line, and maybe this goes through the origin and maybe this point here, which means the slope would be up 5 and over 2. So the slope would be 5 halves. But then if we take a look at some perpendicular lines that go through the same, go through any points there, let's just take a look at this one here. Maybe it goes through, this point here and this point here. That would be down 2 and over, you can see I'm not exactly right, maybe it's this point here, and over 5. So this would have a slope of negative 2 fifths. Well, these two things right here are opposite reciprocals of each other, 5 halves and negative 2 fifths. So slopes of perpendicular lines are opposite reciprocals. Opposite means that they are different signs, so if one's positive, the other's negative, and reciprocals means that they're flipped, so 2 over 3 and 3 over 2 are reciprocals of each other. And so let's just do some real quick problems here that deal with this. We want to find the slope of this line, and we want to find the slope of a line that is parallel to this line. So in order to find the slope of a line, we're going to get it into slope-intercept form. So I'm going to subtract 2x from both sides first. I'll have 7y is equal to negative 2x plus 14, and that's by subtracting 2x to the other side. Then if I divide everything by 7, my equation in slope-intercept form is going to be y equals negative 2/7 times x plus 2. So the slope is negative 2/7. So if I want to find the slope of a line that's parallel to it, the slope of any line, that's m, the slope of any line parallel to this line is also going to have a slope of negative 2/7, because slopes of parallel lines are the same. So what could be the slope of any line perpendicular to it? Well, the opposite reciprocal of negative 2/7 is 7 halves, positive. So the slope of anything perpendicular to it is going to have a slope of 7 halves. Well, let's take a look at another one. We want to find the slope of a line that is perpendicular to this line. So again, we're going to put it in slope-intercept form. I'm going to subtract 3x from both sides, so I have negative 4y is equal to negative 3x plus 8. If I divide by negative 4, my slope-intercept form is going to be y equals 3/4 x, that's because the negatives cancel, and then minus 2, because 8 divided by negative 4 is negative 2. So the slope of this line is 3/4. The slope of a line perpendicular to it is going to be negative 4/3. All right, so are these lines parallel, perpendicular, or neither? Well, we know the slope of this line is 3. So we need to figure out what the slope of this line is. So again, I'm going to put it in slope-intercept form. I'm going to subtract 2x from both sides. I'll have negative 6y is equal to negative 2x plus 12. And if I divide by negative 6, I'll have y equals negative 2 divided by negative 6 is 1/3 x. 12 divided by negative 6 is negative 2. That means the slope of this line is 1/3. Well, they're reciprocals of each other, but they're not opposite of each other. They're not parallel because those would be the same. They're not perpendicular because they're not opposites of each other. So these are going to be neither parallel nor perpendicular. All right, so number 4, we want to write an equation of a line that is parallel to the given line that goes through the given point. So this has a slope of a half, which means the slope that we're going to use is also going to be a half because parallel lines have the same slope. And we're going to use our point slope formula. Y minus the y value, which is 1. That equals the slope, which is 1/2, times x minus -4. Well, that's x plus 4. So I'm going to start by distributing the 1/2. I'll have y minus 1 equals 1/2 x plus 2, because half of 4 is 2. I'm going to add 1 to both sides, so I'll have y equals 1/2 x plus 3. So we know it's parallel because the slopes are the same. But does it contain this point? Well, there's a nice way to check to see if it does. We could just plug in -4 in for x, and hopefully we'll get 1 back out. We know that 1/2 of -4 is -2, and -2 plus 3 does give us 1. And so that point is included in the graph, and it is parallel to that line, and so we have what they were asking us for. Let's take a look at number 5. A little bit more challenging, this one, not only because now they're not asking for a parallel line, but a perpendicular line. We want to write an equation of a line perpendicular to the given line that goes through this point, and we don't really know what the slope is here by looking at that equation. So we're going to start by finding the slope by putting it in slope-intercept form. If I subtract 3x from both sides, I'll have -2y is equal to -3x plus 6. If I divide by -2, I'll have y is 3/2 x minus 3. 6 divided by -2 is -3. And the negatives here cancel each other out. -3 divided by -2 is 3/2. So the slope of this line is 3/2. But we want to write an equation of a slope that's perpendicular to that, so we're going to use the slope of -2/3. And we're going to use this point. So it's going to be y minus the y value, which is 1. That equals the slope, which is -2/3, times x minus the x value, which is 3. So we're going to have y minus 1 equals -2/3 times x minus 3. If I distribute the -2/3, I'll have y minus 1. All right, not sure where I was after my doorbell rang, but we're going to be back at it here. So I'm going to use the distributive property and take -2/3 times x, which is -2/3 x. And then -2/3 times -3 is a positive 2. Then when I add 1 to both sides, I'll have y equals -2/3 x plus 3. And so again, we want to check probably to make sure, first of all, is it perpendicular? And the slope is, did I use the wrong slope? Yeah, I did. No, I didn't. So the slope is what we want it to be, -2/3. That's the opposite of, the opposite reciprocal of 3/2. And we want to make sure that it does go through this point. So I'm going to plug in my x value. That's my domain value, 3. And if I plug in 3 here, -2/3 times 3 is -2, and -2 plus 3 is positive 1. And so I do get my range value, my 1. And so this is a point, this is an equation of a line that is perpendicular to that given line that goes through that point. And this is what our homework is going to be about today, plus a lot of review. And so we will have you work on that, and we'll see you tomorrow in class.